Hello everyone, in this video we are going to solve the next problem. Okay, so first I will read the problem, then I will help you how to solve this problem. So the autocorrelation function of WSS process is given by R double x of tau, which is equal to alpha square, then e power minus 2 lambda alpha, then e power minus 2 lambda alpha, sorry, one second, e power minus 2 lambda alpha, then determine s double x of omega. So here what is our question? Our question, one second, here, so here what is our question? Our question is we have to find out what is s double x of tau. So what do you mean by s double x of tau? S double x of tau is nothing but it is a power spectral density. So here also we need to calculate the power spectral density for the given autocorrelation. So first write the formula to calculate power spectral density. So the formula to calculate power spectral density is this one, that is minus infinity to plus infinity or double x of tau e power minus I omega tau into d tau. So in this formula you are going to substitute what is the value of r double x of tau. It is given in the question itself in all the problems. So here r double x of tau is going to be alpha square into e power minus 2 lambda into modulus of alpha. So in this result I am going to apply here. Then what happened after applying the results? We are getting this step. So here look at here in terms of tau we are going to integrate. So alpha when we are integrating in terms of tau, the remaining variables we have to treat as constant. So here alpha square is going to be a constant, so that can be kept outside. So the remaining value, I'm just looking at the remaining value. So in remaining value I just have splitted the intervals into two parts, in minus infinity to 0 and 0 to infinity. So when we splitting into two parts, it is very easy to integrate. Okay, so minus infinity to plus infinity can be splitted into minus infinity to 0 and 0 to positive infinity. So both are equal. Okay, so that is why I just have applied this rule here for getting better result in a short time. So after applying this, then I am just looking at my terms. So here I have two terms in terms of e. So base same anchana, we can add the power. So I just have added the power in both the terms. So after adding the power I got this result. So here so just look at here. Now we have only one integration part, e power 2 lambda minus I omega into tau. Similarly here the minus of 2 lambda I omega tau into d tau. So I am going to integrate. So e power, if we integrate e power x, the answer is e power x divided by the coefficient of x, it is 1. So here I am going to integrate the given part with respect to tau. So after integrating, it is e power x, then we have to write the coefficient of tau in the numerator, in the denominator. So the coefficient of tau is going to be 2 lambda minus I omega. Let us come to second part. In second part, it is also in the same form, e power x form. So here also, if we are integrating this part, then we are getting e power minus x divided by the coefficient of tau is going to be written in the denominator. So it is minus of 2 lambda plus I omega. So after this step I am going to apply the limits. So limits, first upper limit, then lower limit. So upper limits, it is 0. So when you apply instead of tau as 0, so it is e power 0. Anything power 0 is 1 divided by anything power 0 is equal to 1. Therefore it is 1. So 1 divided by 2 lambda minus I omega. Similarly in the second part, so if you when you substitute infinity, it will become 1 by infinity. The value of 1 by infinity is going to be 0. Therefore the second lower, when you applying lower limit, your answer is 0. So let us come to second part. The same concept here also we are going to use. So the answer, after applying the result, the answer is 1 divided by 2 lambda plus I omega. Therefore, after now take LCM, then simplify it. So after simplifying, we are getting was s double x of omega. So here, look at here, s double x of omega is nothing but it is a power spectral density of the given function, autocorrelation. Thank you.